The rocket travels vertically at a speed of 800 miles per hour. The rocket is tracked through a telescope by an observer located 10 miles from the launching pad. Find the rate at which the angle between the telescope and the ground is increasing 3 minutes after liftoff. Alright, so we have our triangle here. We have the rocket at the top, launching pad, and the observer. Theta is the angle of the telescope in relation to the ground. Um, so that angle is going to be equal to tangent because we have an opposite and an adjacent side. So we have our height over the distance from the launching pad. We know that the rocket is 40 miles in the air because it's traveling at 800 miles per hour for 3 minutes. So I'm not going to plug that into the equation yet because that makes it harder. But so we can say that tangent equals h over 10. Now, since we're finding the angle at an instance of 3 minutes and we need to find the rate of change of the angle, we're going to need to take the derivative with respect to time. So d over dt equals the derivative of this equation. Alright, so we're going to have to take the derivative of tangent first. Now to do that, it makes it a lot easier if we take the derivative of sine of theta over cosine of theta, which is equal to tangent of theta. So we're going to have to use the quotient rule and implicit differentiation. So low d high minus high d low, all over low. So we take cosine times the derivative of sine with respect to time. So that is, and because we're taking the derivative of an angle with respect to time, we're going to use, we're going to multiply cosine times d theta over dt. Then we do the opposite, or we do the opposite on this side. So we're going to end up with sine, and the derivative of cosine is negative sine, and then same thing, implicit differentiation. That's all over cosine squared of theta. Alright, so we're going to use this trig function here. Sine of theta squared plus cosine of theta squared equals 1 to simplify this mess of an equation. And so the cosines become cosine of theta squared, and the negative signs become sine of theta squared. Alright, so then those cancel out. And if you factor out the d over dt, then you end, or the d of theta over dt, then you end up with d of theta over dt over cosine of theta squared, and then that is equal to 1 over cosine of theta squared times d of theta over dt. Then we can take the 1 over cosine squared theta and turn that into secant of theta squared to make our algebra easier. Alrighty, now we get to take the derivative of the other side of our related rates equation. So that other side was h over 10. That was our opposite over our adjacent sides. So we can say that that is equal to 1/10 h. Again, we have to use implicit differentiation. We're going to take the derivative of the height with respect to time. And so we can say that then this becomes 1/10 dh over dt. Okay, so now that we have taken the derivative of tangent and h over 10, we have secant of theta squared times d theta over dt equals 1/10 dh over dt. Alright, so now what we have to do is some fun algebra stuff. So because the problem is asking us for the rate, we're looking for the change of an angle over time. So we're looking for a rate. So that means we're going to want to solve this algebraically for d theta over dt, because that's our rate. So we divide both sides by secant theta squared, so you can see that here. And then we can use our algebra to move that 1/10 into the denominator. It becomes 10 secant theta squared. And then we're going to cross multiply to get dh over dt times cosine of theta squared, and we know this is cosine again because it's a reciprocal of secant. Alright, so now that we have a cosine back in our equation, we have cosine of theta squared, we need to plug in for that cosine, and because cosine is adjacent over hypotenuse, we need to use the Pythagorean theorem to solve for the length of the hypotenuse, which, based on this, 10 squared plus 40 squared equals c squared. C equals the square root of 1,700 miles. So we plug in that adjacent over hypotenuse and square it because it was cosine of theta squared, and that's still divided by 10. And then we can simplify that down here to square 100, and the square root of 1,700 is just 1,700, and that's still all over 10. Then just do some arithmetic here to simplify that to 1 over 170. Then if we remember from the beginning of this problem, the derivative of height in respect to time is the rate at which the rocket is traveling, which is 800 miles per hour. So we can plug in for dH over dt is 800. So 1 over 170 times 800 is 800 over 170, which is 80 over 17 degrees per hour.